Assalamualaikum and hello to our fellow friend and our lecturer Dr. KERK. So for today I will be present for the introduction of work, energy and power. So why do we use energy, work and power? To understanding work, energy and power, help explain how force cause motion and energy transformation. These principles are essential for designing efficient machine, optimizing athletic performance and improving everyday tasks. So for the next one is, what is work, energy and power? Work is the force that we apply over a distance, while energy is the capacity to do work existing as kinetic or potential energy. So for here we know that energy has two types of energy, which is kinetic and potential energy, while for the power is the rate of doing work or transferring energy. These concepts are fundamental to analyzing movement and energy use. And for the next part, I will talk about problem statement. So for our problem statement for this presentation will be the tug of war competition. There are two teams that are pulling on opposite end of rope. Team A has 4 participants, each weighing 70 kg. And for Team B has 3 participants, each weighing 80 kg. And the rope moves 2 meters towards Team A over the duration of 10 seconds. The mass of the rope is 20 kg. And it starts from rest, and we can assume the rope and the ground are frictionless. So first we need to calculate the force applied by each team. Then after we done with it, we need to calculate the work done by each team. And for the next one is the acceleration of the rope. We need to calculate the acceleration. And to the last one, we need to calculate the kinetic energy of the rope. After we calculate all of that, we need to find the average rate by team A and determine the force team B needs to apply to each equilibrium. For the last one, we need to determine which team is the winner.
Now let's take a look for the question 1. Calculate the force applied by each team. So first we need to know the formula for the force is mass multiplied with the gravity. For the team A, they have 4 participants and each of them is 70 kg. So you will get the total weight of team A is 218 kg. And multiply with the gravity given in here is 9.8, and you will get the force for team A is 2714 Newton. Same like for the team B. For the team B, they have 3 participants and each of them is 18 kg. And you will get the total weight of team B is 214 kg. Multiply with the gravity and you will get the force of team B is 2352 Newton. Okay, now calculate the work done by each team. The formula for the work is force multiplied with distance. The statement already given, the distance is 2 meters. So the work by team A is 2744 Newton multiplied with 2 meters and get the answer is 5488 Joule. For the team B, 2352 Newton multiplied with 2 meters equal to 4704 Joule in negative, because it is the negative work done by team B. So next, calculate the acceleration of the rope. The formula for the acceleration we are using in here is summation of force equal to MA. So the summation of force is 2744 Newton minus with 2352 Newton equal to 392 Newton. So we need to find the A. Then 392 Newton need to divide with 20 kilogram and get the acceleration is 19.6 meters per second square. Okay, next, calculate the kinetic energy of the rope. The formula for the kinetic energy is 1/2 mv square. For the first, we need to find the value for the V. So we will using the formula W equal to kinetic energy. Kinetic energy formula is 1 over 2 mv square minus 1 over 2 mu square. Since the rope start from rest, which means u equal to 0, then the left is 1 over 2 mv square. So first we need to find the W, because we can find the W equal to F multiplied with S. For the F, we will using the summation of force is 392 Newton multiplied with 2 meter, and get the answer is 784 Joule. Substitute into the equation, which is 784 Joule equal to 1 over 2 multiplied with 20 kilogram multiplied with V square. Solving for the V and get the answer is 8.85 meter per square. So now we can find kinetic energy. So substitute into the formula, 1 over 2 multiplied with 20 kilogram multiplied with 8.85 square, and get the answer for kinetic energy is 718.4 Joule. Okay, now we need to find the average rate by team A. The average rate means in here is we need to find the power. The formula for the power is W is work divided by T is time. So the work done by team A is 5488 Joule, and the time is already given in the statement, which is 10 seconds. Just substitute the value into the formula, the power, and get the answer for the average team by the average rate by team A is 548.8 point. If the question want you to find the average rate for the team B, it is same like how you just find the power for team A. You just need to change the value for the work and the time if the time is changed. So next, determine the force team B need to apply to reach equilibrium. The equilibrium means in here is the force applied by both team must be equal. So we want to know that how much the force team B need more to same the force for team A. So we just need the force team A minus with the force team B, which means 2744 Newton minus with 2352 Newton, and get the answer is 392 Newton. 392 Newton. The value this value mean is this is the force is more need to apply for the team B to same the force for team A. So the rope will be not moving into the team A and team B. That's all.
Finally, we want to determine which team is the winner. The winner is determined by the team that moves the rope in their direction. Since the rope moves 2 meters toward team A, they are the winners of this tug of war. For the conclusion, we found out that using Newton's second law, we calculated that team A force of 2744 Newton and team B is 2352 Newton resulted in a net force of 392 Newton and an acceleration of 19.6 meters per second. Applying the work energy theorem, team A work of 5488 joules increased the rope's kinetic energy to 784 joules, reaching a final velocity of 8.85 meters per second. Team A power output was 548.8 watts over 10 seconds. To achieve equilibrium, Team B needed an additional of 392 newtons of force. The 2-meter movement toward Team A confirmed their victory, showcasing the importance of forces, work, energy, and power in such competitions.